know if I can see my preview yet to know if I'm up there or not, but welcome. Somebody in chat can maybe give a brother a hand. Okay, I think we're looking pretty good. Yeah, all right, here we are. We're live. I'm just going to pull chat on the side. Okay. Well, nobody here yet. That's okay. So my name's James. I'm going to be, this is my stream channel. I'm going to be streaming my work on some open source libraries that I maintain on Hackage and some that I contribute to. And I'm going to be doing it all in Haskell, pure lazy functional programming language you might have heard of. So thanks for joining. If you're just following along, I'm just coming in. Welcome. Basically, I started this channel for a few reasons. One, just to show what I work on, and mainly really because I still find that a lot of people on the internet, I don't know if you heard this, but they say things like Haskell's impractical programming language. It's meant for researchers. It's a research language. Or on the flip side of the coin, if you're not quite experienced, you're just starting out and you don't know Haskell's a good language for you, you hear things like, ooh, Haskell's very difficult to learn. You have to learn category theory and all these really advanced concepts in order to use it and be productive. So it's better to stay away and go for something easy. And in my experience, it's just not true. I picked up Haskell seriously a few years ago. I've been shipping Haskell code into production for a little over a year, and gotta say, a pretty happy camper. So this channel, I'm hoping to show what it's like to. I want to build like kind of a series of projects with you, and I want to keep them like realistic, show the practical nature of how Haskell helps us, and kind of limited in scope so we can do a few of them. And my first idea for the first project I've had kicking around the old noggin was to build a key value data store in Haskell. So a key value database, kind of like if you've heard about Memcache or Redis, something like that, is basically a database that lets you kind of connect to it, give it a key, and store some bytes at that key, like a blob of data. I don't know, strings of text, an image, whatever. The idea is that later you might come back, give me that key, and I'll give you back your bytes. Or you might come in and like delete the key, and then I'll forget about those bytes and kind of erase them from my memory. I want to do this because I think it's a project with enough scope that we're going to have to like dig into some real world use libraries in Haskell and really push the ecosystem, push the language a little bit beyond kind of like hello world. And also because it's limited enough in scope that we could probably finish this in, I don't know, a few months or something like that. Nothing too big, and we can try a different application domain. Maybe we'll do a compiler next, or maybe we'll do a web application. I don't know. But I think that's gonna be a good first one. It'll be interesting because we'll have to touch a whole bunch of areas. We'll touch multi-threaded coding. We're gonna touch data structures, and we're gonna touch parsers and kind of dispatching actions and how to structure an application together. So what the stream isn't going to cover, I'm not going to be teaching Haskell from like fundamentals or first principles or basics. So if you're just starting out, don't change the channel just yet. Stick around, but maybe look at it as something to look forward to. Like, what does writing a full application look like in this language? Also, what does it look like for someone to get stuck once in a while and have to figure things out? And how do you figure things out in Haskell? Because I'm not an expert. Remember, I've only picked this language up a few years ago. I've been pushing code to production for a year, but I haven't really touched a whole lot of different application domains with Haskell yet. So I'm kind of just stretching my legs with this too. And it might help for you to see someone do the same thing and get stuck and pick up those little tricks you don't really get from all the books and tutorials on how to get unstuck and how to like look up the documentation and where to go, things like that. So stick around for that. And if you're more advanced, maybe stick around so that you can teach other people in the chat some of the tricks and answer some of their questions, or maybe you just help me once in a while get unstuck as well. So again, thanks for coming by. We're going to get started with this project, and let's just get to business. So, what are we going to build? We're going to build a key value data store, a key value database. And that's going to entail a few things. I think the thing I really want to focus on for this project is like really two main areas, reliability and kind of simplicity, and I'll explain what those mean. So reliability, when you think of a database like that we're building, we don't want to take up as much memory as we possibly can from the operating system until the memory manager's out of memory killer comes along and kills our process. That would be an unreliable system. So what we would like to do is, when I mean reliability, I mean we're going to try and keep the scope of how much memory we allocate to the data store limited and fit for whatever the user tells us. So if they say, you're only going to take up 8 gigabytes of memory, little database, we'll say, okay, we'll never allocate anything outside of 8 gigabytes, no problem. We're going to have to make some caveats, though, in our application, because we're going to be writing this in Haskell, which is on GHC, which has a runtime system. The runtime system has garbage collection. It has all that dynamic allocation stuff that we can't really directly control so much. So we're going to have to try and structure our server so that we don't overtax that runtime system so much, so that we can at least say that, okay, if you configure us with 8 gigabytes, we won't use any more than that. Caveat that the runtime system is probably going to need, 500 megs, a gigabyte, a gig and a half, whatever it is. And budget accordingly, dear user. And so if our user budgets accordingly, then we can at least provide those guarantees and everyone can feel safe and comfortable. And there's a lot of other reasons why you want to do that as well. But I really want to focus on that for this project. And the other thing I mentioned was simplicity. So I wanted to make sure, not that writing a database, or a key value database even, is terribly simple. We're going to encounter a lot of things that aren't exactly easy. So we're not going to conflate easy with simple, but I do want to keep simple to mean like the scope of the project. And maybe a little bit of the architecture if we can. So simple that the user, we're only going to support like those 3 basic operations. Hey, Slate Heartache. Yeah, okay, thanks. Anyways, where was I going? Right, we wanted to keep the server simple in that we're going to only support those 3 operations. We'll keep it in memory, so we won't do persistence. Maybe we'll try later on, but we're just going to do basic in-memory database, and that's about it. Okay. All right, so for our overall kind of architecture, there's going to be like 3 main areas that we're going to have to focus on. We're going to be doing the server itself. There's going to be the data store, the backing store, and probably like the application. And the application will be like all of our parsing and protocol handling and back and forth. The server is going to basically hold on to all of our resources. So the socket we're going to listen in on, the reference to the data store, things like that. And the data store is going to be kind of like the index and the data structures that back the key value database. So that's that. So let's get started. All right, so I use Stack as my build tool. I use Emacs as my editor. It's You don't have to use Emacs. I recently got GHC IDE set up, um, and this is all in Windows. I'm pretty new to developing software in Windows, so things might be a little bit bumpy at first. And you don't have to use Emacs because GHC IDE is pretty great, and it allows you to use kind of like any editor you want. So stack, we're going to create a project, and I'm going to call it Rosby. That's kind of a very minor character from Game of Thrones, who was the Master of Keys in King Robert's court. I think in like book 4, not Game of Thrones, Song of Ice and Fire book. So, anyways, cute name. Okay, so we got the stack template, set up the default templates. Just cd into there, and let me know if the font settings and everything are great. You can see the code and everything. So I might need to change up the color scheme just for the stream to make it a little bit easier to follow along. So if it's too hard to read, don't be quiet. So the default template, I don't think, to my knowledge, Stack has an LTS out yet with GHC 8.10.1, which is what I've used to compile GHC IDE with. And for better or worse right now, you kind of have to keep your project, whatever version of GHC you compile it with, the same as whatever version of GHC you compiled GHC IDE with. So we're going to be using 8.10.1, and hopefully it's not going to cause us too much grief. Hopefully no grief. So I'm going to add that to my stack.yaml here. -8.10.1. Then what I like to do after I set up the template is just to build it right away, because it kind of gives you some default code to compile, and that just is like a little sanity check to make sure that everything's working. Cool. And for some reason, linking on Windows is like pretty slow. Compiling large projects in GHC sometimes can get pretty slow too if you're not careful. But we're going to try and be careful. Okay, so I compiled, and then we just checked that it worked by going like that. Some funk. All right, thanks, Ankart. Thank you very much. Okay, so yeah, it works. Great. That's how you know that all your build tools set up right. And I'm just going to check that GHC IDE is set up in this environment, is going to work in this environment. This should just pass fine as well. It's just another little sanity test. Oh no, 3 files worked, 1 file failed. Okay. I was afraid this might happen. It just means we need to actually like have Cabal as a dependency in our package. I think that's mainly just so you can get the inline like documentation and hover over. I'm not really sure how it's going to affect things. If somebody knows, let me know. But I think it's 3.2 in these. Call 3.2. If I'm not mistaken. I think that's the one we want. And then we'll need to add it to our package.yaml. I'll just try that over again. Okay, cool. So I kicked the tires on GHC IDE, and I was a long-time intro user, and it's really good. There we go. So it's going to work now. There's a whole bunch of errors on there. I'm not really sure if they mean anything to me yet, but it seems fine. But it's pretty quick. Like, it's really fast. It's coming along really nicely. So if everybody's waiting on like not using Haskell because of the IDE situation, I think it's going to be resolved pretty soon. Looks like they're doing really good work there. Really happy about that. Okay, so first things first, let's look at the default file it gave us. This is where some func is defined that our main calls. Oops, Sorry, I'm going a little bit too fast here. HIE is going to start off here. Okay, cool. You can configure, by the way, this GHCID thing, these little popovers to go away. I'm going to leave them in because I think for the stream they're going to be good, so that you guys can see, or you can see the types as I kind of like hover over them. Pretty useful. The other thing that we get with the default template is this main. This is kind of like where our application's executable that comes from, and it just calls some func here. So I'm just going to get rid of that. Rosby.server is a pretty good name for a module there. And we'll start off with the server part. The way I like to approach writing like programs and new programs in general is just to get something to the screen as quick as possible and just keep chugging away from there, one step at a time. So go there, we'll go into source, create a Rosby, and create server. Yeah, sure, create that for me, cool. Okay. Rosby.server. My typing will improve. I actually have a really fast typing speed, but I can't type when you watch me. I don't know why, it's a thing. So, okay, we're going to put our little run server function here just to be IO. It's going to basically do the same thing as SumFunc for now. Just to make sure. Rosby reporting for duty. That's probably pretty good. Yeah, nice and official. And then the stack build command, that's kind of like your make. It's going to like look through all your project files and compile everything. I pretty much should have, I think I only really use stack build for the most part in stack exec. There's some like cool Docker integration and like other tooling that I have used with it, which is why I stick around with it. But I think that's all we're going to be using for now so far. So while that's building, oh, we're almost done there. That's cool. And then we'll just go Rosby-exe. That's kind of the default. I think I'm going to change the name of that later on. I don't like the -exe thing. We'll leave it like now. Rosby reporting for duty. Great. Okay. So now we have it printing out. It's got our run server function. The server, like we said, is going to kind of be the entry point to the whole thing. And what I want to do now, I think, is just kind of get it to run, like print this out like we did before, but just get it run in a loop continuously until either we like kill the process or maybe type in a special command or something like that, like quit. And we're going to do that by going into our do. Actually, we'll just take that, put that there. We'll just leave. Actually, I kind of know what's going to happen here, so I'm going to import some things. I'm going to control.monad. That's going to give us a function we need to do our looping. And I'm going to import system.io. I'm going to put the string, just ignore that for now. And then we're going to loop, where our loop function is going to take our command and check if it equals commit quit. If it doesn't equal commit, we'll just call ourselves again and just loop infinitely like that. Small baby steps. So let's do that. We get the command from the getLine function. Super simple, not too complicated. And then we're going to use unless. That comes from control.monad. We're going to put a boolean here. And if it doesn't equal that, then we'll just call this function, which is loop. That's it. Let's try it again. I'm going to see if fast does anything. It probably won't at this stage, because again, the linker is going to be the slowest thing in the universe. But when this does compile and we run it, then we should see it kind of print out that line and then just sit there waiting for input. And then hopefully once we type in quit, it'll quit, or we can control C and kill the process. Okay, cool. Rosby reporting for duty. Welcome, Rosby. Master of keys. Right. And it quits. Hurrah. Okay. Well, that's pretty good so far. The next step, what are we going to need to do with our server? Basically, I'm going to take kind of like a little bit of a shortcut, I think, for the next step, because I sort of know where this is going to go. I think I'm going to just jump right into setting up our monad transformer stack, and we're going to just start out with MTL. I think MTL is like, you know, it's well supported in the Hackage ecosystem, so there's a lot of libraries integrate with it that we might end up needing to use. And if we find later on that, you know, it's not really cutting it for us and we want kind of better structure to our application, we can look for something a little bit more advanced. You might have heard of like effect libraries and things like that. I've been learning a lot about them lately. We might move on to something like that. And the beauty of Haskell, I find, is that you can refactor like crazy in this language, thanks to the helpful compilers. So MTL is a pretty good default if you don't really know what to use yet, I think. So that's what we're going to do. Okay, so without further ado, I'm going to just create a new type here for our server. And it's going to have a little one field in it, run server, and run server, we'll keep it super, super, super simple right now. It's just going to be IO like before, which means we're going to have to rename this thing here. So we'll just call that server and change the type of it. Okay, cool. So it's still giving us type errors here, which is fine. I'm kind of expecting that right now. And you can see it's expecting, could match this up with IO or server or whatever. That's because we're going to need to do some things to our server type in order to start using these IO actions in here. If you haven't seen this before, I don't know how deep I'm going to get into like explaining monad transformers at this point in time, but I may take like a little digression once we get a little further ahead, just to at least give you the gist of it if you haven't encountered it before. I used to find them kind of like freaky when I was first learning Haskell, and it drove me nuts for the longest time. But once like a lot of things in Haskell, once you kind of like butt your head against it and really like work on learning it, and then you learn it, and then you go, gosh, that wasn't so hard. Why would it seem so hard? It's kind of like teaching my little girl how to ride her bike. Like it took forever for her to hop on that thing. And then this summer, like within 2 days, she learned it like that. And she was like, I don't know why that was so scary. So monad transfer is kind of the same way. It's like riding a bike. That being said, we're just going to derive a bunch of things. We're going to drive applicatives. We're going to derive functor. We're going to derive monad. And we're going to derive monad IO. Which I think we're going to have to like import control.monad.trains, I think, which means we're going to need to add MPL to our package. Package on, yeah, there you go. Yeah. This is where we're going to add our dependencies to our library. Add a little stanza here. Yep, that one. I'm just going to drop in MTL there. I don't know if HIE is going to like pick up on that or not. Just fine. It doesn't look like it's picking up on much of anything actually at the moment. I'm just kind of disappointed. What is that? I have to restart the workspace, maybe? Usually it asks me to like, do you want to import all these files into a project? Like, excuse me, it hasn't really done that yet, so I don't know what's going on there. I might have to have a little bit of debug. Oh, there we go. That's good. That's what I wanted to see. So you see there, it's asking me to like, do you want to add the generalized new type deriving extension? And I'm like, sure, man. let's do that. I don't remember the exact command for it, so I'm just getting used to this. I'm just going to like look for it and unpack. Suggestion, something like that. Describe session. Definition. Oh, I know it's got to be a part of the thing. Yeah, why did it seem so hard? Definitely does sum up a lot. It's the worst. And a lot of like other stuff I've learned has been like that too. Like I'm working through linear algebra, and geez, some of that stuff I'm just like, what the hell is a field? And a lot of my mind is just resists it. It's like, no, I don't want to learn it. It sounds so hard. But you just realize, oh, it's just a thing. It's no problem. So this isn't great. Having to like manually type this in, which I don't like doing. But it's fine. It's okay. I'm still going to get a type error though. And that's because now I'm just going to put lift IOs in front of these all over the place, and then it'll be fine. It will. See, super fine. We're good. Let me build this and just check it out. Okay, cool. So while that's building, let's just go for a little miniature monad transformer, poorly explained by your host, James, the Agent Ultra. Okay, so the idea, I guess, is that monads themselves in general don't really compose in a very general way like functions do. And some monads compose together, some monads don't. It's just the way life is, friends. And I'm not here going to teach you all about monads, but I'm going to be kind of really quickly kind of describe what we're going to do next. The next step. So a monad transformer, a lot of people talk about it like a stack. It's just the way it is. And basically what we're doing when we stack a bunch of these together is we just create one giant super monad, I like to call it. And the convention is you always have I/O at the bottom of your stack. It's like good old friendly I/O is always there. And above it, you might have other effects, like maybe you need to, I don't know, log stuff. So you have a logger. And that'll give you functions for logging things. And maybe you also need to carry around some references to stuff. Like we will later on. We'll need to carry on references to sockets and things like that. So you have like a little reader monad on top. These all have like transformer versions of them that obey a particular interface. And when you stack them all together like this, which we will end up doing over here, as you'll see later on, this kind of lets us write functions just inside of server that now we kind of like add the ability to do logging inside of our server type, and we add the ability to get things out of our reader into the server. And we also can do I/O actions in our server type, which is what we're just doing right now. That requires us to add these little type classes to our type that add those methods to it, so that like Haskell's type class resolution can figure out that server implements the monad IO interface, so it has access to the monad IO functions and things like that. And so when we want to do IO, that's why we have these lift IOs in front of our normal IO functions. So that's because we're lifting it up into our server type, and we have to like lift things up the stack. We'll probably only get into lifting a little bit more when we start writing our own monad transformers. When we start getting to the store, and if we want to like do a monadic interface for that. But for now, I think mostly we'll just do lift IOs. You'll probably see lift IOs and stuff like that. So let's just see how our project compiled. I don't need to alt tab on here because it's Cool. We got an exit failure because we forgot to change main. Okay. I'm gonna need to come up with something for that because I like to be able to see the type errors across the whole project. Anyways, app. Main. Of course, run server isn't just going to cut it anymore. Run server needs something else. It needs server. Now that works, and I wasted all that time trying to cover up the compile time with an explanation. Or nada, but we're learning something. We're learning that it's okay to make mistakes with Haskell. It's fine. Go ahead. You don't have to be a super magnificent computer science researcher to get good stuff done. Haskell's your buddy. Okay. Helps you out. Okay, so Rosby reporting for you, just like we had before. Okay, cool. And we should be able to quit. Great. Super dope. How are we doing for time? Gosh, it's only 8:41. I wonder how far we're going to get today. Maybe farther than I had thought. Okay, so that's great. We have lift.io. We have our loop doing stuff. So let's continue on our monad stacking journey. And maybe we'll add, I don't know, we're going to need like a host and a port at some point. I don't know if we want to carry that in the reader. Let's add logging. Let's do logging next. Because, you know, putting print statements around the place is great and it's cute, but we should get rid of that as quickly as possible and just have the logging. For that, we're not going to write our own monad logger on the stream. There's already a great library for logging called monad logger. I'm just going to bring up a browser tab for that. Break that out here. So, how to find stuff, obviously on Hackage. That's kind of the main place. Stackage, if you're using Stack, that's probably the place you want to go so that you're looking at the right documentation for the package that you're going to be using from Stack's LTS. This is Hackage. I don't think they're terribly different, but look at Stackage for the most part. Do as I say, not as I do. But I think they're pretty much the same between the two. So, monad logger. So when you see a library that is compatible with monad transformers and MTL, you're in luck. Because it means it's going to integrate with your stack of monads pretty well. So how to do that? I'm just going to add the monad logger package to our package files. So when we build it, it'll download the package and all that stuff. Basically, all I have to do is derive a monad logger instance to make sure that we get the logging interface for our type, and add the logger to the stack of our type. So let's go do that now. I'll show you what that looks like. It's really simple, really straightforward. So let's just do that. Monad logger. Boom. Import. Should probably actually stop at some point and like make a Git repository for this before it gets too big, but whatever. Having too much fun. So monad logger. We're gonna have to add the monad logger interface here, and we're gonna add it to our type. A monad logger of IO of A. And oh, sorry, that should be. Probably not that. Oh, what's it called? It's probably like logging T. Yeah. Okay. My bad. A logging T of IO of A. Okay, cool. And now we can get rid of like lift.io here, and we should just be able to log it out. So let's look at kind of what the rest of this library does, what it gives us. Log debug. This uses template Haskell, so a common convention you might see is TH, capital letters. Template Haskell. Template Haskell is kind of like compile time macros for Haskell. Really, really powerful stuff though. Um, and we might just try that out. Shot. Okay, we just have to do like $sign log debug. Rosby reporting for duty. Yeah, $sign. Strike like this. Log debug. You might need to turn on overloaded strings, which should just be on by default. I'm going to pull a language pragmas out of the files. I don't like putting them in the files. I'll just put it in our package configuration later. Overloaded strings. Is that not the right? I didn't type it out right, did I? Oh, I can click. Cool. Well, that's something. Who knew you could use a mouse with Emacs? How can we tell if a library is compatible with MTL? That's a good question, PureFP. One way is that it'll just say it in the documentation. T to do, which might be in the contents for this one. So this one doesn't exactly say, so you might see it in the dependencies list, see MTL there, and you might also see that if it kind of implements those common MTL type classes and it's in the library, then you know it'll probably be an MTL compatible library. So hope that helps. Usually most people are pretty familiar with the package descriptions and will say, yeah, this works with MTL. Or it's meant to be used with MTL. You're welcome, sir. No matter. Okay. Why does it think we have an empty do block? That's strange. Oh, I didn't add template Haskell, of course. And it doesn't know that for some reason. Okay. Cool. Now it knows. Now it's good. All right, so we got rid of that, and let's just test, see how logging looks with our new program. Cool. Okay, that's what I was kind of expecting to happen. So once we start stacking things on, we're going to start end up having to change our kind of like happy little run server function. And that is, we're going to do it this way. We're going to do it like this. We're going to go to server. That's cool. I'm going to change it to a good old start, which is going to be type of IO. I don't know if that's a good name. If you can think of a better one, I don't know. I don't even know if we need to do here. But we have a linter. We'll add a linter along. Maybe it'll tell us later on if we don't. It's safe not to have one. So what we're going to need to do with this logging now that we have logging T stacked on top of our IO, we call this run server. We're getting like the wrong type back from when we call this on our server. We're getting like a logging T of IO of A. And we ultimately need to give our main entry point an IO. So we got to peel off this logging T, basically, is how I look at it, taking the layer off of that stack. And the way we do that is by, you'll see these little run functions. Run logging T, probably. Run, yeah, here's a bunch here, like run standard out logging, run standard error logging. These give you this library gives you a few ways to run the logger. So you run the logger to peel off the effect. Once you get down to I/O, you can return that. So we're going to peel off the logger here by doing that. Run standard out logging t, and we'll give it run server, return the logging t to it, and then it'll peel off the logger, and then return it something in I/O. If you're a super Haskell programmer and you know monad transformers better than I do, feel free to answer questions or correct me in the chat. But that's how I look at it. So running standard error logging t, that should fix that. We need to fix main to just use start now, which is nicer, I think. Now main doesn't really do any setup, which is a good sign. And we can just build. Cool. That should be linking, so that means we're probably good here. And we'll see you logging. This is the linking system. I wonder if there's a way to like run Haskell interpreted, so I can just sometimes like on other platforms I'm used to using Linux, I can just run it with build dash fast with the dash fast and dash reload or file watch, and it just kind of constantly rebuilds the executable constantly. If you have any other tips, please feel free to share. So yeah, we should see the same thing as we saw before, only now it's in a logging message instead of just being printed as standard out that we've got here. So we see the little debug tag there, Rosby reporting for duty. Quit. Bonus. Okay, cool. That's pretty good. Let's take a pause there to create our repository. Here. Okay, we'll just add everything. Yeah, just stage it all. Oh, everything. Oh, stage everything. Cool. There we go. Yes, GHCID is super awesome. I like it when I'm like teaching. Thanks for the link. Yeah, I like it when I'm teaching teaching people. I've used it before when I'm teaching people because it kind of like leaves the type errors up, and you can see the type errors across the whole project. Which I should probably set up something for that in this as well, because I like being able to see that. So maybe we'll use a little GHCID action if GHCIDE doesn't satisfy. Okay. Yeah. Okay. So that's staged. Let's commit. Oh, jeez, I forgot. I haven't set up Git on this machine for this. Yes. Oh, jeez. Oh no. At me. I don't know if I can set it up. Oh dear God. What have I done? Instant fix up. No. It's not going to commit, is it? Unable to auto detect email address. Oh. Okay, yes, thank you. Sorry. I will fix this. This is my email address, so if you want to email me and be pen pals on the internets, we can totally do that. I'll have to add my keys and stuff later. Again, new machine, setting up for Windows development, which I haven't really done before. So, okay. Now hopefully I can commit everything. Great. Okay, cool. Initial commit. In the beginning, this is not usually how I word my commits, only the first one. I don't know, it was kind of dumb. I think we like, last one. Okay, cool. That's great. All right, so we'll push that up to GitHub. Create a repository for that. GitHub. Wow. Rosby. Simple, reliable, hopefully, key value database. Sure, it's public. We don't initialize it. No, thank you. Cool. Let's add our remotes. That is, yeah. Add. Windows, I don't know how to do you. Okay, copy. Paste. Oh my god, no. This is so sad. Can't paste it. Can I paste it? Some other buffer? What have I done? Okay, I'm just gonna have to do it on the command line. That's bad. Let's get remote add origin. Oh, I can't even. Oh my god. Okay, you know what? I'm gonna do that later because that's really boring. So, promise. Let's get back to the server. Okay, so let's continue on with our journey of stacking things one on top of the other. We have logging in here now. We're probably going to want happy old reader T on top with a logging key of IO of A. And we're going to get that from control monad reader. Yeah. And then we're going to add monad reader, context type here. So what is a context? I don't really have a super great name for this thing, but it's just like a record or some data structure that holds stuff we might want to access from our functions in our type server. So that could be like configuration, for example. Like we said, from our user, we're going to have to take configuration about the size of the store that we're going to build, and we'll probably have to take other things too, like, I don't know, host, a port, various things like that. So we're just going to add some fields here. So like context host. It's not actually going to be a string. Port. It's not actually going to be an int. We're just putting this here for now. Because we like types. We like good strong typing, and we like not mixing up things we didn't mean to mix up. So int isn't a good thing for here when we meant a port. So we'll make a type for port instead. Make a type for. We'll probably have a library. There's the libraries for handling this kind of stuff. So we'll get types from there. That's good enough for now. Like when you're just starting out, just use what you got. Don't complicate things. So that's the context. This should compile again. And what's really cool about this now is that my server, this function that returns a server type, or implements a server type, however you want to think about it, now has access to reader. So I can now get the host and the port out by using the reader function called ask, which comes from control reader ask. And I can log, and I can do IO, all in the same kind of function. I can't do like other random stuff. I can't carry state through here. Unless I really work things up. I'm sure there's probably a way I could work around the rules, but maybe, but probably not. Like, Haskell's type system is going to make sure that I'm not using any of these things incorrectly. So that's kind of like why, I guess, MTL is considered pretty good practice and pretty good library. It kind of lets us separate these things out. I kind of like it personally because think of what you want about Dijkstra, but maybe it was Tony Hoare. I think it was Tony Hoare, actually. So I'm not going to mention Dijkstra. Forget him. Tony Hoare wrote some pretty cool papers and pretty cool books and stuff and talks. And he said there's like really two schools to software development. You can either make software so simple that there are obviously no errors in it, or you can make software so complicated that there are no obvious errors in it. And I like to think of I find that this kind of stacking of effects together, while sometimes you run into limitations of it, does kind of give you that ability to like kind of squint at this code here when you're doing code review and say like, you don't have to worry about is it doing random state or stuff. You might have to worry if it's doing IO, but then everything's flagged by this annoying lift IO function. So I don't know, it kind of takes my mind off of things a little bit. Lets me kind of autopilot a little bit. In code review, I could just kind of check the types and make sure it's steady and it works. So yeah, anyways, I mean, this is not perfect, but we'll get into that later as the project grows. Yeah, now I could do ask. I probably should have set this to compile while I was going off on that tangent. Yeah, there we are. So now we got reader. Again, we're getting a type error here because now we got to like peel off that reader effect as well. So it's just getting, this is now getting, not getting a run standard error logging, it's getting a reader back. So let's peel off the reader before we give it to the logger will peel off the logging, and then we get the IO again. So run reader T. And run reader T with our server, it's going to take some context. We're going to have to initialize some context here. So let's just hard code something in there for now, just to see it work. Local dash dash. It was the year 8989. Good year. Okay, that should compile again. We probably get I don't know, clever dollar sign in there. Get rid of some parentheses. Yeah, that looks okay. And this should compile again. Okay, cool. It did. Super. So that's the reader. We'll probably stuff other things in there than the host and port, but let's just stage that. Check on our code. That's probably fine. Let's commit it. Thank you. We'll just say modified server. Add T to server type. Capture the configuration. Full configuration. Context. Something like that. I'm sure that's totally, we'll totally look back on this code and be like, yeah, that's why we did that. Okay, cool. Yeah, so that works. I got the stack. As I knew it would. Okay, cool. Rosby report 3. Oh, well, I mean, it doesn't really prove that we got it, but if it compiles, it's probably correct, right? So let's just do the, I don't know, let's just not shot, show port. I called it post. Text. Okay, so that's only defined on string. At because of showing port. Whatever. Let's pretend it works. Okay. Another great annoyance with Haskell is, and it's not. I mean, it's annoying when you first encounter it. It's kind of annoying as you go throughout your life, but there's a reason for it. There's a plethora of different ways of representing strings in computers, friends, and Haskell is no stranger, knows all about this. You know, the base library comes with string, which technically we're not going to really use in the long run in real production code. But it means we have to like import text to get this text type, which is not in base, which is very frustrating. And you end up writing a lot of code, or at least not a lot, but you end up writing a fair bit of code to handle the two. Sometimes some libraries are like, we want to be compatible with base, so we're going to use string everywhere. And some libraries are like, no, we must use text. And so, like Monad Logger, it uses text. So you're just going to have to trust me that it's there, because I don't want to bother with that at this moment unless we have a lot of time. Which looks like we do, so we might actually do that. I don't know. Okay, we're going to need it anyway. Why not? Where are we at right now? We didn't really change anything. Yeah, okay. So let's go ahead and add it. Why not? We're going to need it anyway. It's almost guaranteed. Always just add text. And I think, no, we'll do that in another change. We'll move all the language extensions into this file as well, so we don't have to have them in our source files all over the place. Okay, so we'll add text there. Text is over here. And that'll give us handy-dandy functions for converting from strings to text, I think, hopefully. Pretty sure it does. There's your text type, pack, string text. Maybe not the safest, depending on what. Let's do that, just to show it. It's cool. That's what all the cool kids do. Okay, so what I got to import again? I haven't imported this library in a long time because at work, where I use Haskell, I use custom preludes that kind of have built-in functions for converting between the different types because I find it so annoying. It's just data.txt. Okay, that's fine. Import data.txt, please. Okay, cool. And now I can pack in my pack. I don't know if I can pack not show. Maybe I can. And maybe I gotta wrap that all up so that's okay. Haskell's fine with it. Okay, we're back in business. So now we can finally see in our logging message that there's actually a host import there. Yeah, yeah. So I think what's the next thing we should work on? Maybe we should like get the host, start getting the configurations from somewhere instead of hard coding them in our program. That might be a good next step. Oh, I'll find out. Feels pretty good. All right, stack. Exact. There you go, localhost 899. Beautiful. I think later on, hopefully this library has a way for us to kind of customize how these log messages get printed out. I don't know about you, but I'm a fan of structured logging these days. I log everything out using JSON, so that a lot of my tooling that listens to those logs can pick up on things, and then I can have nice little ways of querying my logs based on like properties and stuff, rather than just trying to like grab through text. But we'll get to that later. Something to put in our task backlog. Okay, Rosby reporting for duty. Yeah, so where to get configuration from? Let's just go ahead and commit that. I don't know if we should be committing the qualify. The main modification here is the server and the development environment. So I don't have this on me. Yeah, so we got a text between. Cool. So getting configuration. There's a lot of different ways we can approach this. And when I'm writing servers, usually I like to pass in configuration through environment variables. And that's mainly so that when I'm like my CI or my deployment, my continuous deployment environment needs to fire up a bunch of copies of my server, I can configure them from one place and just kind of inject all the configuration of there. I don't really like configuration in general. Configs annoy me, especially when there's too much of them, too many of them. I like to choose like sensible defaults. Just give me the default and pick a good one, so that I don't have to, because I have to make like a bazillion choices when I'm designing a software system, and if somebody's choosing to use our server in their application, then I don't know, it seems like a drag to bother them with like, okay, now you have to like, configure this option and this option. So anyways, environment variables would be good. Maybe we can just get them, I don't know if we want to get them from the command line maybe as well, so that we can like test things easy. There might be a library for us. So I've kind of written this stuff by hand before. It just takes up a lot of code. I'm just wondering if somebody has written a library for this before. Haskell, configuration management, confer. Hopefully it's just super small and simple and does what we want. I have tried configuring a Haskell application. Yes, I have. Have you? Oof, let's see. What solutions confer? Great. Okay, that's what we're here for. I like ergonomic. So default config. Create a config, which defines sources our config will be reading. by default CLI brands, I like defaults. env vars, I like those. Ooh, and not properties files. Okay. Default config, awesome. Then we use get from config with some arbitrary key, scope of server config, and we use our config, warp settings. Okay. So that means now that we can do, okay, server port. And also, okay, so it like prefixes all of our environment variables, so we can be like a nice happy application in the ecosystem of other processes running on some shell. That's nice. And okay, cool. And we got many different defaults. Okay, so when picking libraries to do stuff for you, the trade-off we make is that like it's gonna every little dependency we add is gonna make things more convenient for us. It's also gonna add a little bit of compile time to our project, a little bit of complexity because it's a little bit more documentation. Our contributors are gonna have to like read up on and learn. But I don't know. In this case, it feels like it's going to be pretty lightweight. Like 3, 4, 5, 6. Yeah. Not too many other dependencies. It depends on. We already have container text. All right, let's do it. Let's try out confer or we choose you. So I'm a bit of a stickler. I like to keep my dependencies kind of in order. And once we really kick off this project and kind of get it off the ground, we'll probably add some pretty good tools for automating all of that, so we don't really have to think about it. I don't like messing around with it all that much. Confer. Hopefully that's in stackage. Let me just double check that. Yep, okay, cool. Well, yeah, 16.2 I think is what we just built with. Oh, very unstable. Don't use it in production just yet, folks. Dang. Why not? Now I'm scared. I don't know. Should we just try it out? What's the harm in just trying it out? Depends on 5 packages. It's used by only 3 packages. Okay, maybe there's a different library we should use. Seems like, I don't know. Seems like it could be okay. Maybe not. I don't know. Why not? Why not? Don't use it in production. Okay. Now I'm scared. You've scared me away from your library. I mean, good if it's not ready for production yet. Does anybody else know of any other libraries? Let's just try another quick search just in case we're a little bit hasty. Ooh, we got a follow? Thank you. Thank you very kindly, friend. I'm just getting used to the streaming thing, so I don't have it yet, but I will totally shout you out for being amazing. And let me just try searching for that again. So Haskell configuration. Okay. Maybe there's a better one. Config INI, configuration tools. Let's look at that one. Safe and type safe. We like type safe. That's cool. Try that out. Doll. That's a whole other universe. Following us up is really cool, but I don't know too much about it, and it doesn't seem like what we need our server just yet. Catch configuration errors. I wonder how you can do that. Oh, HOCON. Human optimized config notation. Okay. Cool, I guess. All right, one more string. See, I'm already kind of like, I don't know about this, friends. Not quite. I was really, really rooting for confer there. That seemed really nice. Oh. Up parse applicative base. Ah. I don't know, friends. Okay. I think we're going to have to just give confer a shot. We're still a young project. If we need to get away from confer, I don't think we'll have a huge issue with it. But it seems like a small enough package that we can look at the code later and see if we should be worried or not. Maybe the documentation's out of date. I don't know. Let's just give it a shot. Live free. Move fast. We got confer. We'll just build. And then while it's building, we'll go to our source. We'll go to Rosby server. I don't know if we want to start like a new module for getting our configuration, so that maybe if this library doesn't really turn out for us, we can provide kind of like our own interface for it. It's true. It is pretty easy. I mean, yeah, it kind of is. The hairiest refactor I've done so far, I think, at work was doing this. I did this like really big data migration project where I was kind of trying to generate a typed schema for this database of like untyped JSON documents, schemaless JSON documents, right? And there are enough of them and so many different variations between them that the way I decided to go about it at the time, there are better ways now, but the way I decided to go at the time was to try and parse it with ASON. And that all went well and good, but I was just writing the most kind of like basic sloppy Haskell, just get it to go, get it to work. Just get it to parse. Like, you can fix it later. You can refactor it later. And it was a really big mass of code. Like, it was ugly Haskell. It was just so gross to look at. But it was fine because I wrote some libraries with a friend of mine, and I went in and refactored all that code using that library, and I had this monstrous data structure that had like 50 some odd cases in some types. And refactoring it was tedious, but the compiler, followed me along every step of the way and wouldn't let me forget a case. You just work through them one by one until it compiles again. So it can be done. Okay, so it built, so download the library and add it, whatever. Cool. How do I use it again? For package. Okay, cool. Yeah, so let's just try and like get it to work. Okay. Draft imports. What do I got to import here? Data confer, or just confer. Let's try that. Confer. Okay, cool. GHCID found it, see? GHCID is pretty sweet. With intro, if I added new dependencies or mix things around, I'd have to like restart intro to it, which wasn't the worst. Just hotkeyed it. That's kind of cool. Just picked it right up. Okay. So let's just get this magic config option object. It's kind of looks like it runs in I/O. So um, I don't know. Let's just do it over here for now. We're just trying things out. Config default, I think it is. Default config. Thank you. Yeah. Rosby. Get the configs for Rosby, please. Yeah, I mean, that already kind of looks like it type checks. Everything's cool. Interesting. I don't even know what the type of that thing is. Config. Okay. I wonder if we could just add it right to our context reader. And then maybe we don't even need the context host import. Let's check it out, confer. Let's try it. Okay. So let's just do that. I'll move you down here. Add config to you. Pass you in. Okay. And then we can ask for you again in our server. And then let's try it out, folks. Log debug. What do we want to try asking for first? Something that's not there, maybe. How do we ask for something? Get from config. So I might have to lift IO this. Oh, we're just asking for it. That's already in IO, so that's fine. Okay, cool. You don't have a text version of it, so I can't just debug you out. Let's save that. Host. Let's just ask for host. Server host. Server host. Get from config. Some key, right? Yeah. Host. And the config. We're probably going to get, yeah, couldn't match IO with us. We're going to have to lift IO that. Still not happy with this. Oops. I did it the wrong way. And you're not happy because scope. And I didn't need to fix. Yeah, of course I did. Okay. No instance for typeable arising out from use of get config. We need an instance of typeable. Oh, I guess it probably wants to know the type of the thing we're getting out from it. I mean, that kind of makes sense. Let's read into this a little bit more. Okay. Okay, so it recommends creating things like this. This type process defines what the create type is. Driving user generics. Like that. Love them generics. Don't understand what you're looking at. Okay, Shadow Wolf. I'm sorry if you came here looking for Destiny. I might not have configured my channel just right. I'll fix that, I promise. I'm building a server in Haskell, a key value database. I don't know if that makes more sense to you or not. It might make even less. I'm sorry. Hopefully it's cool. I want to stick around. But yeah, not Destiny, which I sometimes used to stream once in a while. Okay, so we create a default config for app config with some very defaults, okay, and then, okay. So then we can get our app config back out, okay. That's all right. I think that's okay. Let's try that. Okay, so let's move the context. Are we doing half an hour? I think I got about a half an hour left to finish this up. So let's move our configuration out of the context, and then we'll keep the context around for holding on to like the actual the sockets and the nvars and TOFs and various other things we'll get into. So we might not be able to have show up. Okay, let's just put it here for now. Rosby config. And pretty much copy this here. Cool. So our context host and context ports. We can even go ahead and make that text. Probably best. And actually, I forgot to mention when importing texts, this library is designed a certain way. It's meant to be imported qualified. So we're going to just import the type. I guess how we do that. Remember, qualified. That's T. We give it a qualified name. That's because like a lot of the names in text clash with a lot of other libraries in the base, things like that. So that's what we're going to do there. Fix that. Okay. We wanted to make configuration, and then we're going to draw generic for it. So we need to do that. We need to do that. Okay, compiler happy, thank you. IDE. We're going to get an instance of from config. Not for app config though, but for Rosby config. That one. And then we got to set some defaults for our configuration. That's nice. I like this so far, actually. Okay, so let's create some defaults. This is like the exciting part of like starting a new server project, right? What should the default port be? It's like a rite of passage. Tell me in the chat if you have a good idea for what we should default to. Okay, let's create this instance. Whatever. And it's not app config. Config def. Okay. And okay, how do we get default values again? Set port. I don't know if that's special magic or what. Config secrets to the string here, and the example is just text. Okay. So I guess what they're doing here looks like in the example is that maybe this settings type will have some default instance configuration port as well, so we can like stack default configurations together and we can cleanly separate them in Slack. I'm digging this. I'm digging this. I like it. Okay, but otherwise we can use just plain old values. So we probably don't even need to call that context anymore, but we'll change that. call that localhost. Anybody got a good port? No? Alright. I'll stick with good year. 1990, 1990, 92 is good. 93. Yeah, I think it was 93. 93 was the year I saw it. Stick with that. Doesn't really matter, we'll change it later. Okay, so that's default config. That's cool. What do we do next? Now we can pull it out. And hopefully it'll know the types of things we can call. Yeah, okay. Get from root config. Tell the type is app config or Rosby config. Cool. Hopefully that works. Okay, so this is going to be still type error-y because we don't have type configs. Which means this is going to be type error-y. Fix that. Okay, what else is bad? One thing I like having is just we'll just get rid of all this. Don't need those parentheses anymore. So, okay, so now we can do this. Configs. And we don't want to get root for config. We need to get from root config. And we need to tell it what the type is. I like this notation. Is that what you want? A lot of the times Haskell will just be like, looks like you're trying to do this. Do you want to add this extension? I'll just be like, yeah, sure. Except for a few exceptions, it's usually okay to do that, I think. There are a few exceptions you have to be worried about, though. Some people think like orphan instances and overlapping instances can be a thing. They have a point, so be wary when you see that, but I think it worked okay. Okay. So that got a config object out of the root config. What can we do with this thing now? I guess we can just pull values. So let's just pull out. Well, since we changed the type to text now, I think for our context host, let's just do that. Let's just log that out. We can do that now, and then we'll commit it. And I think we'll call it an evening from there. That'll be context host. We have to get something. How do I get my call? Oh, wait, I got it just right. Otherwise, we can fix dirt. Configs, no. Not IE. Of course, you couldn't do that. Because I need to wrap this up. Okay, cool. Super. Hooray, it compiles. Okay, this is probably going to work. Let's try. Okay, much better. So, once this compiles, we'll commit it. We'll call it there, I think, for the night. I just want to thank everybody again who did show up, who showed up for the Haskell stuff, and I appreciate what I'm doing here. For showing up and watching and following along. Next week, I'll be streaming probably the same time. once a week on Tuesday nights, 10 after 8 Eastern Standard Time. I'll be getting the stream all configured and set up better so I don't attract any more unwavering, poor, lost souls, and attract more Haskell developers. So if you like what you saw today and you want to follow along, this code will be up on GitHub. You can share it around. Check it out, follow, subscribe, do what you got to do. So you can come back next week. Okay, cool. So let's run that again. And there we go. Thanks again. Host, local host. So now we're getting our configurations out. Cool. I wonder if we can change that now, actually. Instead we can do stuff on the command line with this. So I'm just going to play around with that a little bit. If I can use my computer properly. Cool. So I should be able to do it like this on the command line. I wonder if we can do this. Rosby, actually, do a double dash there, and here's hoping, folks. The moment of truth. I'm sure there's a trick to it. I just haven't gotten it right yet. But cool. So we got command line. Hopefully, we got command line configurations, environment configs. Take that for a little go on the block there. Check our magic quick command there. Super dope. Okay. Commit that. Yep. And Bob's your uncle. Okay, so the main commit there was on the server. And I don't know if you like this convention. I know everybody's kind of, a lot of people have their own. Kind of picked it up just from, I forget where I got it from. Maybe it's from like the Linux kernel stuff. I can't remember. Anyway, yeah, we had to confer as a dependency. Cool. Okay. Thanks again for tuning in. Thanks again for the follows and subscribes. Next week, Tuesday, 8:10 p.m. or so Eastern. Thanks for tuning in, and hack some Haskell, man. Have a good one.